Hey there, and welcome. Today, we're doing something really cool. We're not just going to talk about the future, we are going to learn how to predict it. We're going to build a forecasting toolkit together, step by step, and turn this whole complex subject into a skill you can actually use. So, let's jump right in.
So let me just ask you, right off the bat, can you predict the future? Now, I know it sounds like something out of a sci-fi movie, but in a lot of ways the answer is, yeah, you can. The skill is called forecasting, and it has nothing to do with a crystal ball. It's all about using what's already happened to make a really smart, educated guess about what's coming next.
And trust me, this is way more than just a fun thought experiment. For a business, this is a genuine superpower. Think about it. Knowing how much to stock for the holidays, predicting when you'll turn a profit, or even staffing your hotel perfectly for tourist season, all of these things boil down to one goal: using data to be proactive instead of reactive. It's about making smart moves before you're forced to.
So here's our game plan. First, we'll talk about the why, the real superpower of prediction. Then, we'll get into making and measuring our predictions. After that, we'll tackle those tricky yes or no questions. Then we'll get into a special case. What happens when time is a factor? We'll look at some simple but crazy powerful methods, and finally, we'll talk about how to choose the right tool for the job.
All right, first things first, let's really nail down this core idea. What are we actually talking about when we say forecasting?
At its absolute core, forecasting is just this: using information from the past to make a prediction about the future. That's it. And the whole point is to allow us to plan and prepare. It's this huge shift from just reacting to things as they happen to actually anticipating them, and that is what makes it so valuable. Okay, it's time to add the first real tool to our kit. Let's say we want to predict a number, like the price of a house. We can build a model for that. But as soon as we build it, we run into a huge question. How do we actually know if our prediction is any good?
And this quote just nails the problem perfectly. If you test your model using the exact same data you used to build it, of course it's going to look brilliant. It already knows all the answers. It's exactly like grading your own homework. You're going to give yourself an A+, but did you really learn anything? Nope. We've got to test it on something it's never seen before. And the solution to this is something called the train-test-split. It's a fundamental idea. We take most of our data, the training set, and we use it to teach the model how to find patterns. Then we hold back a smaller chunk of data it's never ever seen before, the testing set. That's how we find out how well it really performs out in the wild. So how do we grade it? We use these error metrics. MAE is the most straightforward. On average, how far off were we? Simple. RMSE is similar, but it really punishes big mistakes. It's for situations where being way wrong is super costly. And then there's MAPE, which is great because it gives you the error as a percentage. That makes it really easy to understand just how accurate you are.
Okay, but what if you're not trying to predict a number, like a price? What if the question you're asking has a simple yes or no answer? You know, like, will this customer click the ad? Or will this person renew their subscription? For that, you need a different kind of tool.
And that specialized tool is called logistic regression. It is designed specifically for these binary outcomes, where there are only two possibilities. Honestly, think of pretty much any question that can be answered with a yes or a no, and this is probably the model you're going to reach for. It is incredibly common and super useful.
So how do we grade this kind of model? We use something called a confusion matrix. Now I know it sounds a little intimidating, but it's really just a simple grid. It shows us the 4 possible outcomes. The 2 ways the model can be right, a true positive and a true negative, and the 2 ways it can be wrong, a false positive and a false negative.
And that simple grid gives us our scores. Accuracy is the easy one. What percentage did we get right overall? But sometimes that's not enough. Think about medical screening. Precision asks, of all the people we predicted were sick, how many actually were? We want to avoid false alarms. Recall asks a different question. Of all the people who were actually sick, how many did our model successfully catch? We don't want to miss anyone. And the F1 score? That's just a way to find a nice balance between the two.
So far, we've kind of assumed our data points are all independent of each other. But what happens when they're not? What happens when the data is a sequence? When the order of the data is the most important thing? Well, that's a whole new ballgame, and it requires its own special set of tools.
This is what we call a time series. And it's exactly what it sounds like. A series of data points collected over time. Daily sales figures, the temperature each month, the price of gold every year. These are all perfect examples of a time series.
The key thing to remember is that the chronological order is everything. And when we look at time series data, two big components usually jump out at us. First is the trend. This is the long-term direction of the data. Is it generally heading up, down, or is it staying flat over the years? Then you have seasonality. This is a predictable, repeating pattern. Think about ice cream sales always spiking in the summer, or website traffic peaking on the weekends. That's seasonality.
Now, the secret ingredient that makes time series forecasting even possible is a concept called autocorrelation. It sounds complicated, but it just means correlation with itself. It answers a simple question. How much is today's value related to yesterday's value? If sales were high yesterday, are they likely to be high today? If that connection is strong, we can use it to predict the future.
Okay, so now that we get the basics of time series data, let's add our last set of tools to the toolkit. And you might be surprised by how beautifully simple and yet incredibly powerful some of these methods are.
First up is the naive method, and it's exactly what it sounds like. The forecast for tomorrow is just whatever the value is today. If you have seasonal data, you just use the value from the same time last season. I know, it sounds almost too simple to work, but it's an incredibly important baseline. You have to see if your fancy model can even beat this simple guess.
Then we have two more simple benchmarks. The average method says the forecast is just the average of everything that's happened so far. The drift method is a little smarter. It basically just draws a straight line from your first data point to your last one and extends it into the future.
Now we're getting a bit more sophisticated with exponential smoothing. You can think of this as a very smart weighted average. The idea is simple. What happened yesterday is probably more important for predicting tomorrow than what happened 6 months ago. So this method gives more weight to the most recent data.
And finally, we have autoregressive models, or AR models. And this kind of brings us full circle back to regression. It's the same idea, but instead of using a bunch of different variables to predict an outcome, it uses past values of the data itself as the predictors. It directly uses that autocorrelation we just talked about, predicting today's value using yesterday's value. And there you have it. That's your foundational forecasting toolkit. We've gone from the basic idea of prediction, to measuring it, to handling different types of questions, and even dealing with the complexities of time. The only thing left is knowing which of these amazing tools to pull out for which job. We've built this kit together, we've looked at all the tools, and we understand what they're for. So now, the most exciting question is the only one left. You now have the tools to make an educated, data-driven guess about the future. So, what are you going to predict first?